Through the course of this video, I'm going to show you how I drove this stepper motor right here using an H-bridge driver and custom software on the Arduino. I'm not going to be using any of the built-in Arduino libraries for driving stepper motors.
To accurately control the angle of our servo, we're going to need to find the number of steps per rotation. This is a geared stepper motor, which means that we both need to understand the number of steps per rotation of the stepper before the gearbox, and then we're going to have to use the gearbox ratio to find after the gearbox. So to do that, we can use our stepper motor equation right here and plug in that so that we find 32 steps per rotation of the stepper motor. Now, because of the gearbox, and on the data sheet it's a 64:1 gearbox, we multiply that 32 by 64 and we find it takes 2048 steps to do a rotation. Now, I found that this is actually not correct for my stepper motor. It's a bit different that was in the data sheet. And so my gearbox I found experimentally by actually counting the steps for a full rotation. The gearbox is actually 16:1. So my servo actually has 512 steps per rotation. The way my code works is we have two lists, and those are the heart of the entire operation. We have the list of steps right here, and the list of steps will control which order the pins should be high and low in to proceed to the next step. If this list is progressed from top to bottom, that turns the motor counterclockwise. And if you progress from bottom to top, that turns the motor clockwise. Secondly, the way I wrote this so that I can do multiple different actions with the same code is I used a list of operations. This is simply a two-dimensional matrix that contains information on how I want the servo to move. This list of operations is then processed by a for loop inside a void loop, and each operation is pulled off of the top of the array of operations. All of the information is then sent to a function that I've written called moveStepper. This function has a while loop in it, and this while loop, before the while loop, we compute how many steps we need to have to complete the angular motion that is required, along with other things including how fast we want the servo to rotate. So this could be anywhere from 5,000 steps per second all the way down to 100 steps per second. This information is then broken up into little pieces and sent to my makeSteps function. All this takes is a direction, and that direction is then used to actually make a step in the makeStep function. Here it takes the array that I previously mentioned of the list of steps, it peels off the step, the next one we need to make, depending on whether we're going to go clockwise or counterclockwise, and that next step contains the information of what the pins need to be set at to complete the step. This is then sent to the setPins function, which is simply a for loop which sets each pin to that. Then, once this is completed, that exits, this exits, and we go back to the moveStepper function where it figures out what the next step needs to be to complete our operation. As this happens, eventually we've completed the operation and it returns back to the for loop where the next operation is pulled off the stack, and the next one, and the next one, and so on and so forth until we've completed all of the operations. Here we have the code in its actual code form. This right here is the list of operations. On the left we have the direction, in the center we have the speed, and that's just a percentage of our maximum speed. And this is saying move at the maximum speed, versus here it's saying move 50% of the maximum speed. And in here we have an angle, how far do we want it to rotate. So here's 360 degrees, so that's a full revolution, versus this is 45 degrees. Here we have the step order. This contains the information that encodes what the pins need to be set at to complete that step and then the following one in order. I also included a section for half stepping, and that's where two windings are on at the same time, allowing you to stay in an in-between position. So there's 8 steps per rotation, or 8 steps before the cycle repeats, which means there's twice the number of steps per rotation. We have void set up, which does what you'd expect, sets up serial and other pins. Void loop where we're actually going through and peeling off each operation. As you can see right here, we have each of the elements in the control pattern, and it just does some analysis on that and runs the move stepper command. The move stepper then takes that, just as we described previously, does some calculations on it, and then actually steps way down here at the bottom. Following that, we then have the make step command. This is where the step is actually made by setting all of the pins to their proper values to make the step. And this is the code support for making half steps, and this is the code support for making full steps. Here we have the code that actually sets the pins to the values they need to be to complete the step.
The servo will now complete all of the tasks that are set out and outlined in order in the control pattern array in my code. It starts out by rotating 360 degrees forwards at the maximum speed, reverse at the maximum speed, then reverse again at half speed, as seen there, and then back forwards again at half speed. Next, it will complete the series of precise angle turns. There's 45 degrees, 90 degrees, and then 180 degrees is last. Following the completion of that, it will rotate continuously counterclockwise, as seen there. Thanks for watching the video. I hope you learned something.